Hello guys, so in this video I'm going to go over one of the most simplest common techniques of integration, which is called U-substitution. And you may have briefly covered it in Cal 1, but in Cal 2 you do use it a lot. And in differential equations in Cal 3, etc., you do use U-substitution a lot, so it's better to become very familiar with it early. So when to apply U-substitution. So when to apply it. Well, apply it when the x terms have a power difference of 1 and cannot be simplified algebraically and cannot be simplified. So that's when you would apply U-substitution. So notice in this function we have right here, we have a function x divided by the square root of x squared plus 1. So the first thing that we should notice is that x squared has a power difference greater than 1. That's exactly 1 to x raised to the 1 power. And notice it's inside a square root, so we cannot just simplify this as easy as just dividing x divided by x squared. So that's not going to work. So what we do is we select our u to be the function with the higher exponent, just because its derivative will cancel out, and you will see here shortly. So select u as x term with higher exponent. So in this case, our u is equal to x squared plus 1. The next thing we do right here, which is the key step, is we take du. So our du is equal to 2x d times dx, and then we solve for dx. So our dx is equal to du divided by 2x. And the next step is to substitute dx back into the function, so that way we have everything in terms of u. So I'll write it out. So substitute dx back into function. So we're gonna go ahead and do that. So our integral of x divided by x squared plus 1, but keep in mind that we did substitute it as u, du divided by 2x. So now notice we can cancel out the x's and we can pull out 1/2 because of the 2. So that's exactly what we're going to do. So 1/2 integral of u to the inside a square root is 1/2, but since it's in the denominator, it'd be negative 1/2, so u to the negative half times du. And now all we do is we integrate everything with respect to u. So that's what we're going to go ahead and do. So we're going to go ahead and integrate this problem. So this problem is (1/2) integral u to the negative 1/2 times du. So when we integrate this, we add 1 to the power, so it's u times half divided by 1/2 plus c. And we multiply this by 1/2. So notice that this 1/2 is on the denominator and this one's on the numerator. So basically these cancel out. And if you want to see that step, I can perform it real quick over here. So 1/2 times 1/2 on the denominator reciprocates to be 2/1 times u to the 1/2 plus c. And notice the 2's cancel, the 1's cancel, so we're left with u to the 1/2 plus c. And the next step would be to substitute u. So what was u? U was right here. Our u was x squared plus 1. So x squared plus 1 raised to the 1/2 plus c. That would be our final answer. Or if you want, you can leave it as a square root. It doesn't really matter. But either one would work. I'll leave it as a square root. That's probably, I guess, more proper. But that's basically how you perform u substitution. So when to apply u substitution? You apply it when your x terms have a power difference of 1 and cannot be simplified. So basically the idea is that the derivative of u will cancel out the other x term. And if you don't get a cancellation, then you probably did something wrong, because that's what you're aiming for. You're aiming for to get everything in terms of u. And when you get everything in terms of u, because you substitute dx back into the function, your x's should cancel. And then you get everything in terms of u. And from there, you integrate with respect to u, and then you substitute your x term back into u. I hope that makes sense. Please let me know. And thank you for watching. Hello guys, so in this video we're going to go over how to do the concept of u substitution with this problem, example problem, which is 4x to the 4th power divided by the square root of x to the 5th power plus 105. So the idea is to select u, or when to apply u substitution, apply it whenever the derivative of one of your x terms cancels out the other x term. So whenever you see a power difference of 1, that's how you know the derivative of the higher exponent will cancel out the derivative of the lower exponent. So when to apply u substitution? Apply when the one of the x functions, or when the difference between the difference of powers is exactly 1. And when your x terms cannot be simplified. When you cannot simplify. So that's when you apply u substitution. So for this function, we have, the first thing we're going to go ahead and do is we're going to pull out the 4, because we don't need it for solving this. And it makes it a lot easier every time you pull out a constant. So the function that we're going to look at is x to the 4th divided by x to the 5th plus 105 inside a square root. So select u as, so next step is we select u as x term with higher exponent. So select u as x term with higher exponent. So our u in this case is going to be equal to x to the 5th plus 105. Our du, taking the derivative of this function, will be 5x to the 4th plus the derivative of that is just 0 times dx. And the next step is we solve for dx. So in solving for dx, dx is equal to du divided by 5x to the 4th. So now the next step would be to substitute in dx. So plug dx into integral. So when we do that, we have 4 integral x to the 4th divided by, this is now u raised to the 1/2 because it's a square root. And then our dx we substitute as du divided by 5x to the 4th. And notice how our x to the 4th terms cancel out nicely. And our 5, we can pull it outside of the constant, outside of the integral sign as a constant. And we're left with 4 to the 5. And then du, we can raise it to numerator by having it be a negative exponent. Negative 1/2 times du. So the next step would be from right here. The next step would be to integrate. Now that we have everything in terms of u. So now that we see no x's, we integrate with respect to u. So integrating this, we keep the constant 4 to the 5th, but our u is going to be u negative 1/2 plus 1 is equal to positive 1/2. So u to the positive 1/2 divided by the same thing, which would be 1/2 plus c. And to simplify this a bit further, we're going to go ahead and simplify the constants, and we plug in where we see u, we plug in our x terms, which actually was x to the 5th plus 105. So we're going to go ahead and do that. And we're going to do this all in one step. So we're simplifying the constants and we're plugging our x back in. So in doing so, we simplify 4 to the 5th divided by 1/2 is equal to 8 over 5. Because since this fraction's on the denominator, we reciprocate it and multiply by this constant. So we get 8 over 5. And then our u is x to the 5th plus 105 raised to the 1/2, which is the same thing as a square root, plus c. And that's our final answer. So key steps for u substitution: apply it when the difference of powers is exactly 1, because that's how you know the derivative of your u term with your higher exponent will cancel out the other one, which is what you want. You don't want anything left with x. Afterwards, you take the derivative you integrate with respect to everything in u terms, and then once you do that, you plug in your x, whatever your u variable was, plug in the x terms of it back into the function. And that's how you apply u substitution. I hope that was helpful. Thank you for watching.